In the previous video, we talked about sequences and series in general, just kind of the basics and what, just generalities about them. Now, this is a specific type of sequence and series, and it's called arithmetic. Now, the word is arithmetic, but it's arithmetic when you're using it as a noun, and it's arithmetic when you're using it as an adjective. So I'm not mispronouncing it when I say arithmetic. That's the way you say it when it's describing the sequence. So these are also called linear sequences and series. The key to arithmetic sequences is that you are adding or subtracting the same number over and over and over again. So an example would be like 2, 5, 8, 11, 14. There I'm just adding 3 every time. That's an example of an arithmetic sequence. So here we have a formal definition written here. It says an arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. That amount is called the common difference. So again, all that really means is you are adding or subtracting the same number over and over. And that number that you are adding or subtracting is called the common difference. So let's first just make sure we understand the common difference by looking at these two down below. We have 2, 6, 10, 14, 18. So the question is, what is the common difference? What are we adding each time? Well, we're adding 4 each time. 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 4 is 14. 14 plus 4 is 18. So they usually use a D for the common difference, and that would be 4. Okay, looking at the second one, we have negative 2, negative 7, negative 12, negative 17. So here we're clearly going down, and we're going down 5, so we would say our common difference is negative 5. So if you're going down or you're subtracting, you need to put a negative with it. Okay, so one thing they may ask is they might put it in recursive form. Now we've actually done a couple of these on our homework already, but it says given a1 equals 7, so that's our first term. Our first term is 7, and then it says an equals an minus 1 plus 8. Okay, well remember, this just represents the term you want, this represents the term you have, and this tells you what to do to it. So right now the term we have is 7, so to get the next term that we want, we just add 8, because that's what this is telling you to do. So 7 plus 8 is 15. 15 plus 8 is 23. 23 plus 8 is 31. So we're just adding 8 every time. So that is an example of arithmetic sequence. Okay, now another way they may ask you to do it is by just giving you the first term and giving you the common difference. If you look here, we have a1 equals 2, that's the first term, and then we have d equals 1.5, so that's telling you you need to subtract 1.5 each time. So a2 is going to be 1.5, a3 is going to be 1, you're just subtracting 1/2 each time, a4 would be 0.5. So I'm subtracting 1/2 each time. So again, a1 represents your first term. D represents the number, the number you're adding or subtracting each time. Okay, now this explicit form, this formula right here, you do not need to memorize, but you do need to be able to use. It's going to be on a formula sheet on both my test and on the MSL. So it's not something you have to memorize, but you do need to understand it and be able to use it. So let's talk about each part. Okay, this is the term you're going to be looking for. A1, as it has been all along, is your first term. D is the common difference. And then n is the number of the term you're looking for. So let's just say, for example, that we're using the same information as we were before. So I'm just continuing this bit of information right here, that a1 equals 2 and d equals 1/2. And let's say I decided I wanted to find the 17th number. So I wanted to find the 17th term. So I'm trying to find a17, and to do that, I plug in a1, So A1 is 2. Again, I'm getting this from up here. Plus, okay, n is going to be the same as this. It's whatever number you're looking for. We're looking for the 17th term, so I plug in 17 for n. Minus 1 times d, that's my common difference, which up here it told me was negative 1/2. So I can just plug this in the calculator. I plug in 2 plus parentheses 17 minus 1 times negative 1/2. And I get negative 6. So without having to actually find the first 16 terms, I was able to find the 17th term. So this formula is very helpful. It can help you find any term you want and just that term. You don't have to find any other terms, just that one. Okay, so it says find the first 5 terms if a1 equals 5 and d equals negative 3. So when they just ask for the first few terms, I think it's simpler to just add or subtract whatever number they tell you. So for this one, I would just say, okay, a1 is 5, and I need to subtract 3 every time. So I would start with 5, then I'd subtract 3 and get 2, subtract 3, get negative 1, subtract 3, get negative 4, subtract 3, get negative 7. So that would be my first 5 terms. The one they give you does count. This is the first term. So the first 5 terms would be 5, 2, negative 1, negative 4, and negative 7, because I'm just subtracting 3 every time. Now for this second example, find the 58th term. It's probably not going to be easiest for me to actually write out that whole thing. I don't necessarily want to write 57 terms just to get to the 58th one. So this is where I would want to use that explicit equation that was on the previous slide. So just to remind you, it looks like this. And that is n minus 1 times d. So to find the 58th term, I plug in the first term, a1, which is 2. I plug in n, which is 58. It's the term I'm looking for. Minus 1 times d, my common difference, is 7. So if I plug that in, let's see what we get. 2 plus parentheses 58 minus 1 times 7. And I get 401. So the 58th term is 401. And I was able to figure that out without having to find the first 57 terms first. So that's the benefit of the explicit formula. You can use it to find any term you want. One thing you may be asked to do is write the equations. And if you notice, this one is a little different. They have only given you the list. They haven't said what a1 equals or said what d equals. They just give you the sequence. Okay, well, remember what a1 is. a1 is just the first term, so that means 4 is a1. Because your a1 is just your first term, so that's 4. And remember, your d is your common difference. It's whatever you're adding or subtracting each time. Well, to get from 4 to 9 and 9 to 14, I'm clearly adding 5. So my common difference is 5. So to write the explicit equation, I'm just going to be reusing this up here. So I would plug in an equals 4 plus n minus 1 times 5. That would be my explicit form. And that's the more important one. I'm going to show you the recursive, but the explicit is the more important one. And again, the general form, the thing I highlighted up here, one second, there we go. This right here will be given to you. You don't have to have this memorized. It'll be on your formula sheet. Okay, but the explicit is what we have here. Now the recursive is going to look a little bit different. The recursive, just like we talked about yesterday, starts by giving you the first term. So it would just say a1 equals 4. And then it would tell you what to do to get the next term. So we would say an equals an minus 1. We have to say, okay, what did I do to get the next term? Well, I added 5. So you would just say plus 5. And this would be the recursive equation, because it tells you to start with 4 and then add 5 every time after that. Okay, the final thing you need to know how to do with these is to find a sum. Okay? Now, let me hide this from you. Okay? The formula you see here, the Sn equals n over 2 equals a1 plus an, this is another formula that you will be given. It'll be on your review sheet, or on your formula sheet. Now this is a formula sheet that's made up by the state, by the MSL, so I want to make sure you know how to use it. I'm going to show you what I think is a simpler way than this formula, but like I said, since it's on there, I want you to know how to use it. So this is finding the sum of the first 20 terms. So if you remember, what we're really talking about here is a series, because a series is the sum of a sequence. A sequence is just the list of numbers. A series is the sum of that list, or if you add up all those numbers. Okay, so for example, here it wants us to find the sum of the first 20 terms. So I'm looking for S20. That means the sum of the first 20. So I put 20 in for n, because that's the number of terms. And then A1 is my first term. Well, you just look up here. That's 5. Now AN is my last term. Now that's what I don't like about this equation. You actually have to go back and figure out what your last term is. Okay, well, we can use the explicit formula for that. We're looking for the 20th term. That would be the last term. To do that, we do A1, or the first term, plus n, which is 20, minus 1, times our common difference, which would be 6. We're adding 6 each time. So I get 5 plus 20 minus 1 times 6. If I'm not mistaken, that is 119. Let me double check, make sure. Yes, that's 119. So that's our final term, and we put it in there. So we add our first term, and we add our last term, and then multiply by n over 2. And let's get our calculator, see what this gives us. 20 over 2 times 5 plus 119. And we get 1240. So that's our sum. Now that's how to use the formula that'll be on your formula sheet. Personally, I think there's a simpler way. If you remember, the explicit form is just A1 plus n minus 1 times d. So I could write the explicit form for this one as AN equals 5 plus n minus 1 times 6. That would be my formula. Well, if I want to add all those together, what we learned yesterday is that you can just use a sigma, or you can use the summation in your calculator. So I would just use this formula, the explicit formula, and put a sigma in front. And since you want to do the first 20 terms, I would just do n equals 1 to 20. So you can plug that in your calculator using math 0, plug in the equation, tell it to go from 1 to 20, and you'll get the exact same result. You'll get 1240. Okay, here was the homework from this particular day. Be sure to check my website to make sure this is consistent in case this is from a different year, different semester.